Thank you very much, Cooper. And thank you all for coming this morning. Thanks to Tim Rummage for bringing up this idea many months ago, and it seems like time has passed way too quickly. All right, but so these are some of our local resident dolphins of Sarasota Bay. You'll hear a little bit more about them as we go along. But I want to make the point that I'm here as a representative of a larger research group. The work that we do really requires a village. We have a research team that's based at Mote Marine Laboratory that includes a variety of biologists and works with collaborators from around the world. So the information I'll be presenting today will represent the work of many people, including volunteers, some of them here in this room today, who have helped to make the work possible over the last 47 years. Can't be that long. So, whoops. That was a quick slideshow, let me tell you. All right, there we go. So there are many definitions of sustainability. The one I'm going to work from today is the quality of not being harmful to the environment or depleting natural resources, and thereby supporting long-term ecological balance. And the example I'm going to be working with today is local wildlife, and in particular, large mammals that happen to live in our backyard. Or you can flip it around and say, since they've been here longer than we have, that we live in their backyard. So this could be just considered another cute dolphin picture. But for us, having studied the dolphins of Sarasota Bay since 1970, there's an awful lot of additional information that comes from this about our neighbors in the bay. We can get a lot of insights about them and about what it takes to maintain these animals and have them thrive in the waters that we share. For example, among the take-home messages I hope you go away with today are the fact that these animals have long lifespans. This picture was taken in 2012, and at that point, we had a 62-year-old female and a 59-year-old female in this picture. The 62-year-old female has gone on to reach 67 years as of this year. These are long-term, year-round residents to the area, and they truly are our neighbors. What we do in the neighborhood affects them. There are multiple concurrent generations of relatives in this neighborhood, not unlike communities I've lived in other places where there are families of humans that live nearby, not necessarily in the same house or the same group, but nearby. And in this particular image, we have a grandmother, her daughter, and the grandson, along with a close friend. And finally, these animals exhibit complex social structure and communication, and I'll touch on this a little bit. But they're not just gray bodies that happen to live in the waters around us. They have a complex society that's been built up over many generations and over hundreds, if not thousands of years. So today, I'm going to give you a little bit of history about our program. I'm going to talk a little bit about the biology of the animals, and I'm going to focus on the conservation aspects that we spend much of our time working on with the dolphins of Sarasota Bay. And I would be negligent if I did not indicate a word from our sponsors here. We are a soft money research organization. We get grants and contracts and donations. That allows us to keep going. We keep going beyond the terms of congressmen and presidents, and finding continuing funding continues to be a struggle, but we get by. So today, what I'm going to do is select one of our local residents as an example, and you'll see Killer, and I'll get into the background of her name during questions if somebody wants to put that on their card. We'll talk about Killer because she's as old as our research program is. She was born in 1970. She has a very distinctive dorsal fin, and she utilizes the waters of the Sarasota Bay Dolphin Community Home Range, which goes from southern Tampa Bay down to Venice. But she emphasizes the northern part of that. We first identified her when she was 5 years old. We've seen her more than 1,500 times over more than 40 years. We know that she's had 9 calves over the course of her lifetime, and that 5 of these are still alive, including, and there's a theme here, Lizzie Borden, Lorena Bobbitt, Freddy Krueger, Vader, and C99 just hasn't shown us its personality yet, but it'll get a good name too. From these, we've seen 7 grand calves, and 4 of those still survive. So how are we able to know the details of a dolphin's life in this way? As was mentioned by Cooper, we began our work in 1970 at Mote Marine Laboratory as a pilot project. Nobody knew at that time what dolphins in the Gulf of Mexico or any place really did in terms of holding down residency or moving around a lot. We went out and began to tag dolphins in local waters, and we learned that some of these dolphins could be seen time and time again. As time has gone on, we've seen that that is indeed the pattern. We have local residents to the Sarasota area, and we're able to monitor the same individuals year after year. We've continued the work first through the University of Florida when I was doing my master's, and then through the University of California, Santa Cruz for my PhD, and through a nonprofit Dolphin Biology Research Institute. But since 1989, the Chicago Zoological Society has been the organization that has operated our program and made it possible for us to continue. And we rent space from Mote Marine Laboratory, which gives us a very convenient base located right in the middle of the Dolphins' home range. The primary tool that we use for studying these animals is individual identification, and in particular, photographic identification. These animals have nicks and notches on their dorsal fins that serve as fingerprints. They have to come up to breathe about twice a minute on average. And so it gives us opportunities through getting good quality photos to be able to confirm the identifications of individuals. Over the course of our program, we've documented more than 49,000 sightings of dolphin groups. Within those groups, we've obtained 718,000 photographs. Most of our staff now wears glasses or has other aids to their vision because of having to look at all those. Within the groups, we've been able to make over 147,000 individual identifications of more than 5,500 animals that live up and down the central west coast of Florida. Within Sarasota Bay, within our local resident community, 96% of the individuals are easily recognizable to us. And we have, as I mentioned, over 1,500 sightings of an individual with more than 45 years of data on some of the individuals. So what have we learned from being able to keep track of these animals over time? Number one, we have multi-generational, multi-decadal, year-round residency to the area. The figure on the map here shows 5 dolphins in a column. Those are 5 related individuals from different generations. At any given time, we can have as many as 5 concurrent generations of individuals in the area, but it shows all of their sightings. They don't range very far. Some males may go farther, but for the most part, these are home bodies to a localized home range in the area. We find that this exemplifies the kinds of patterns that we see up and down the west coast of Florida. We've done work in Tampa Bay, Charlotte Harbor, Pine Island Sound, and been able to document the existence of similar resident communities in those waters as well. They're not populations in an isolated, reproductively isolated biological sense, but they're communities in terms of bordering one another. Behaviorally, they remain in an area for most of the time, but there's no walls between the communities. The borders are porous, and animals can move back and forth. Our current community of about 160 residents can span up to 5 concurrent generations. That's very different from saying that we've observed 5 generations over 47 years. At any given moment out of the bay, there may be 5 concurrent generations within a given lineage. As I mentioned before, well, no, this is actually a different point. 96% of the dolphins that are greater than 15 years of age have been observed for 15 to 40 years. This gives you an indication of the long-term residency of the animals to these waters. And finally, from a life history perspective, we found that males can live to be 52 years old and that females can live to at least 67, given the fact that we're still observing Nick Lowe in our local waters. This is a much longer lifespan than what people thought for dolphins previously. Among the things that we do with monitoring these animals is, of course, going out monthly and doing photographic identification. But on occasion, we also do health assessments of the animals to get a sense of what's going on within the health of the population and to gather background information that can be used elsewhere. This involves going into shallow waters with a local fisherman and a long net and encircling small groups of dolphins, bringing them aboard a specially designed veterinary examination boat, running a series of tests, much like you would have when you go to see your doctor. We get indication, well, we do a physical exam, we look at their reproductive condition, we get measures of weight and length, we look at how well their lungs are functioning, we listen for, or we test for how well they are able to hear, since this is a major issue facing marine mammals around the world with increases of human noise in the waters. And we sample for a variety of things, including blood chemistry, serology, functional immunology. We do urinalysis, look at biotoxins, measure environmental contaminants, look for microbes in various orifices, and we conduct genetic testing, including paternity testing. This information is useful for monitoring the Sarasota dolphins over time. It's also crucial for being able to do investigations of populations that are at more risk in other places around the world. NOAA's National Marine Fisheries Service uses the data from Sarasota Bay dolphins as a reference point. When they have a situation such as an unusual mortality event where many dolphins are dying in a bay, or when there's something like the Deepwater Horizon oil spill, they want to understand how those things are impacting the animals in those areas. So they use the normal values that we obtain from our largely unimpacted population here in Sarasota Bay. They do similar health assessments in their areas, and they're able to look at where the differences occur and then pinpoint what mitigation might be possible or build a case for being able to make a difference for recovery operations. And so this map shows the various places where we've done these sorts of comparative studies for NOAA. Much of the effort since 2010 has been up in Barataria Bay, Louisiana. We have it so much better here in Sarasota. I'll just go ahead and say that. It's not a vacation hotspot. But the animals up there have been impacted heavily by the Deepwater Horizon oil spill, and the work in Sarasota has done much to help make the case for getting the restoration funds out of BP. A couple of publications that have come from that and a summary of some of our findings. First of all, the Barataria Bay dolphins did not leave Barataria Bay during the oil spill. There were always some dolphins in the bay, and you can see a picture at the bottom that shows dolphins swimming through oil. As a result of the health assessments, the Barataria Bay dolphins had low adrenal hormone levels, and this was consistent with adrenal toxicity, which is consistent with exposure to oil. The Barataria Bay dolphins were 5 times more likely to have moderate to severe lung disease as compared to the dolphins here in Sarasota Bay. Again, this is a disease that is correlated with exposure to the toxins from oil. Many of the Barataria Bay dolphin diseases were uncommon but consistent with oil exposure and toxicity. And finally, the low annual survival compared to Sarasota, only 87% of the dolphins in Barataria Bay are surviving year to year as opposed to 96% here in Sarasota. And the low pregnancy success, only 20% of diagnosed pregnancies from ultrasound become swimming calves alongside a mom, as compared to 83% here in Sarasota Bay. These were major factors in leading the case for the damages being assessed against BP for the oil spill. So, switching back to our local dolphins a little bit more, we've been able to look at these animals in depth over time. When you look at an animal more than 1,500 times, you do get a pretty good sense of what's going on in the life of that individual. And when you follow it through the subsequent generations, you can begin to define the social structure. Among the findings we've determined from our work here is, first of all, that the dolphins don't live in families such as humans have. Mom, dad, and the kids, that's a concept that just doesn't exist for these dolphins. Dads are all deadbeats. Moms have to raise the kids. The dolphins do not live in pods. I know it's a really fun word to use. It makes everybody sound like they know something about dolphin social behavior. But if you look closely at a pea pod, those peas aren't going anyplace. They're locked in that pod. It's a very stable social structure. So killer whales do live in pods where the structure is consistent day after day, year after year. But our dolphins live in a very fluid situation. It's called a fission-fusion kind of society where individuals will move around over the course of a day. It's kind of like a kaleidoscope. As you turn the wheels, different individuals meet up with others. They may split up. They may come back together again, but they go on about their way. On average, we see a little bit over 3 dolphins in a group, but we have seen groups of over 30 residents together in Sarasota Bay and associated bays. And we have 3 basic social units. Nursery groups are the largest. These are moms with their most recent calves, and they keep their calves with them typically for about 3 to 6 years. Juvenile groups are of mixed sex, and they're trying to sort life out before they become mature. And then the adult males form a very unique structure within dolphin society or within any animal society. They form a pair bond when they reach sexual maturity, and I'll talk a little bit more about that. Who's your daddy? One of the things we've been able to do by obtaining genetic samples from these animals is do the same kind of paternity tests that are done for human beings, paternity exclusion tests. And this is just one example from Killer's lineage. Killer's kind of fickle. Only once has she used the same male for more than one calf, but she's used other males for each of her other calves. And one of her daughters, Lizzie, actually used one of the same males that Killer did for her calf, not her dad. But there is an aspect of this society that rotates through males as opposed to forming a permanent kind of bond with one particular sire. The adult males do form a strong pair bond once they reach sexual maturity. We find that these pair bonds oftentimes stay together until one of the two animals dies. And then they may audition others for a replacement, or they may try to go it on their own. At any given time, about 57% of our males are in a paired situation, and the others either have been in one or are looking. Over the course of a lifetime, 90% of the males will have been in one of these pair bonds. It probably serves them well when they're trying to capture prey. They can work together. If they're trying to protect themselves in battles with other males along the borders, if they're trying to coerce females or maintain access to females, that may be the strongest reason these particular units have formed up and they stay in place. So just to summarize the life history of these animals, we know that females mature at 5 to 10 years of age, and this is based on hormones and when we see them giving birth to their first calf. Males never mature, oh no, that's my human talk. Sorry. Males mature at about 10 years of age. Most of the calves are born during May to July, but they have been born in every month except for December and January. Gestation is about 12 and a half months. And in Sarasota Bay, we see about 83% of our dolphin pregnancies resulting in a live calf alongside mom. Mothers are anywhere from 6 to 48 years of age. Usually there's groans in the audience from women. They have had up to 10 calves that we've seen, one at a time. They only rear one calf at a time. And as I mentioned, they invest about 3 to 6 years in each calf. The fathers, based on the paternity tests, are anywhere from 10 to 40 years of age, and we've documented up to 7 offspring for a given male so far, and we're still conducting the analyses. So the social structure involves complex communication, and we are in a situation here where we know the background information of the local dolphins, because they are here all the time, where we can help with the scientists who are looking at the sounds the animals are producing. They produce a range of sounds. Echolocation clicks, or the sonar, is one you're probably most familiar with. They also produce raspberry sounds that occur when they're socializing with one another. The one that we've been studying the most are whistles, and dolphins whistle a lot. The waters of Sarasota Bay and most of the range of these animals is murky. They can't see each other, so to keep in touch, they whistle. And what we've determined or helped to confirm over time is that each dolphin has its own individually specific whistle that's called a signature whistle. They develop that within the first few months of life, and that stays with them over time. Experiments that we've done with playing back whistles to dolphins during our health assessments have shown that these whistles, these signature whistles, are actually names. It's a very unusual phenomenon in the animal kingdom, but these individuals use their own name, and they respond to other dolphins that call their name, that contact them, their contact calls. And there's still a wealth of other whistles we're trying to understand, but this level of communication, understanding they have the abstract concept of name down. It's not just understanding or hearing a voice over and over again, but the actual whistle structure serves as a name, is a pretty interesting feature for these animals. And we've been able to learn about that during playback experiments, during the health assessments where we're holding the animals and we play recorded sounds to them and see how they respond. And also we put little computers on their backs on suction cups. You can see that in the digital archival acoustic tag. And this stays on for about 24 hours, and it records all the sounds coming to the dolphin and all the sounds being produced by the dolphin. And when you put it on 2 dolphins that are released together, you can actually get the back and forth on them. And you do focal animal behavioral observations to put a behavioral context on that. And all of a sudden, you're starting to unravel how they talk to one another. It's a long process, but it's one that we're set up here to look at and know better than any other place in the world. We recognized early on that we couldn't just study the dolphins in isolation. We needed to put them within an ecological context. And so understanding the prey that these dolphins use and the requirements of those prey has been a major part of what we've been doing, especially since 2004. We've been doing observations that show what kinds of fish the animals eat when they bring their prey up to the surface, which in the shallow waters around here happens fairly often. But we also benefit from the stomach content analyses that are done by Mote Marine Laboratories' Stranding Investigations Program. And so we've been able to look at the fact that these animals eat a variety of fish. Pinfish is the #1 fish in their diet. It's kind of like the filler, it's the popcorn. It's a very common fish in the bay and one that they can get easily. But given the opportunity, they are very selective about the fish that they eat. They go after soniferous fish, fish that produce sound. And that makes sense. The water is murky. They don't want to use their echolocation necessarily to tap fish on the shoulder and say, hey, I know where you are. So by listening for the fish and then zeroing in on the fish that make noise through their swim bladders or that sort of thing, the dolphins are able to enhance their opportunities for capturing those prey. And so they take those noise-making fish disproportionately to their availability in the environment. They select them from the environment. But the top 10 fish in the list include a variety of fish such as pinfish, toadfish, which is a very noisy fish, pigfish, spot, mullet, some menhaden and herrings, sea trout, and ladyfish. And they take a variety of other ones. Many of these fish absolutely require the presence of seagrass meadows and mangrove fringing forests. We don't have a lot of the mangrove fringing forests left. They seem to be threatened to a great extent. We've seen increases in the water quality and increase in seagrass meadows since the time we started our work, which is a good thing. But we need to sustain this to sustain the dolphins in the area. Our dolphins and other dolphins in the Gulf of Mexico face an array of threats. Among them are natural threats such as disease, and I can't really get the pointer at this angle, so just going across from side to side and down. Disease is one of these threats. Failure to thrive for a calf is one of these threats. Red tide, harmful algal blooms are a major threat, either directly through toxicity of the red tide organism or from loss of prey through the deaths of the dolphin's fish. Major hurricanes can destroy habitat and create pollution. Water temperature, we'll talk about later on, is on the rise. We see that these animals do face predation from sharks in local waters. For a number of years, this was not much of an issue when sharks were being fished out, either as bycatch or in directed hunts after the movie Jaws came out. But in recent years, the shark populations appear to be recovering, and we're seeing an increase in the presence of shark bite scars on our dolphins. Stingray barbs are a threat for these animals as well. The stingrays are not chasing down the dolphins, but the dolphins go through very shallow water, and if they bump the bottom where a stingray is, that stingray is going to try to defend itself. And with the decline in shark populations, there was an increase in stingray populations, and so there were more encounters and more serious injuries and mortalities from stingrays. Among the human-caused sources of mortality and serious injury, net fishing is one. When commercial gill netting operations were occurring, occasionally a dolphin would be entangled in a gill net and died. But it was not nearly the issue that the recreational fishermen made it out to be when they got the constitutional amendment passed in 1995 to get rid of the gill nets. A far bigger problem for our dolphins is recreational fishing activity, and it always has been, and we'll talk more about that. Entanglement in commercial fishing gear such as crab traps is an issue for dolphins, for manatees, and turtles. Feeding of wild dolphins is illegal under the Marine Mammal Protection Act, and it creates problems by putting these animals at greater risk. It puts them in contact with fishing gear to a greater extent. Red tide oil spills are a possibility. We were fortunate that the Deepwater Horizon oil stopped 87 miles short of our area, but we were certainly prepared for it. Boat traffic can be an issue for these animals, just like it is for manatees. Pollution from various activities can be an issue for these animals. Habitat destruction and oil and gas development has the potential to be able to do things, but it's something that has stayed off our shorelines here so far, but not elsewhere in the Gulf. In our own bay, Killer, who's been around since 1970, has seen huge changes to the bay. Since that time, there's 3.4 times as many people within the area served by Sarasota Bay and the home range of the dolphins. There's 3.6 times as many boats. Within the lifespan of Nick Lowe, our 67-year-old dolphin, there were very few power boats back in 1950. That's been a fairly recent development. Things have changed dramatically in terms of the insonification of the bay, noise from power boats in the bay. We want to understand why these animals die, and then understand what component of the deaths are human-related so we can try to mitigate those. And so we work closely with Mote Marine Laboratories Training Investigations Program. We help check out reports they have of dead or injured animals. We help recover those animals. They do the necropsies and find out what's happened to these animals. And in a subset of animals that's been examined and the findings have been confirmed, the pie diagram you see down there, a little bit over half of the mortalities could be identified as being from natural causes. A little bit less than a quarter, CBD could not be determined because the animals were not in good enough shape. And then more than a quarter were related to human causes. And those are the things that we as conservation biologists can try to make a difference with. So among the things these animals have to face are boat traffic. We all know that manatees are struck by boats. People mostly think that dolphins are too nimble and too quick to be struck by boats. Not true. Under appropriate circumstances, in shallow water, for example, where they can't dive below the boats and boats are going very quickly, dolphins are struck by boats, and dolphins can die from those strikes. There's approximately 40,000 boats registered in the home range of our dolphins, of our 160 dolphins. We had a grad student who calculated there is a powerboat passing within 100 yards of every dolphin in Sarasota Bay once every 6 minutes during daylight hours. That's a lot of traffic that they're playing in. And they respond to that. They change their behavior. They dive more frequently as these boats are approaching. They tighten up their groups. The sounds from the boats can mask the sounds of the fish, the soniferous fish that they're looking for. So there are issues that come along with that. About 5% of our dolphins have scars from having been hit by boats. Fortunately, most of these don't result in mortalities, but sometimes they do. Like in 2012, we had 4 of our dolphins hit, and there was 1 of those that died. Entanglement in commercial fishing gear is something that does occur. Fishing nets were not that great of an issue before '95, and they're even less of an issue now that they've been outlawed and pushed offshore. But as a result of that change in that constitutional amendment, many of the commercial fishermen switched to crab fishing. And so now what we have at this time of year when stone crab season is in place, we have more than 10,000 individual stone crab traps within the home range just of the Sarasota Dolphins. Each trap has its own individual float line. It's a maze trying to swim through that kind of an operation out there with that many float lines. Many of them are loose with loops in the water in which they can become entangled. And it's a threat to the dolphins, to manatees, to turtles, and to other creatures as well. You can see that from the 2 maps there what happens during just blue crab season on the left and when the stone crabs season goes into play, and many of these traps are out there. A little bit over a year ago, we rescued one of our well-known dolphins named Bill, F262, from entanglement in a crab trap just off Venice. He'd been reported late in the afternoon. It got dark. We were able to get out there first thing in the morning and find him. And we have a video that we can play of us finding him. Fortunately, the waters were very calm off Venice. Fortunately, it being off Venice, sharks did not find him overnight because he couldn't go anyplace. He was anchored by this crab trap. He was a large male. We've known him since birth. He was very lethargic at this point. He'd been struggling for quite some time. With the calm waters, he was able to get to the surface to breathe. Fortunately, the tides were not extreme, so we were able to find him and get a hold of the line. The person who had reported him had cut the float off the line, which made it a little bit more challenging in some regards, but also easier when it came to time to disentangle him. This is about a 550-pound dolphin. For one guy here to be pulling him up by the tail, is just, that shouldn't even be possible. So these animals have no reverse gear. They have no way to untangle themselves. Fortunately, it was a fairly thick line, so it didn't cut in very deeply. But we were able to get it off of him. The wounds are superficial and they healed up quite nicely after that. And then once he realized he was free, he took off. We've seen him many times since then. He's doing fine out there since that time. Yay. One of the ironic things about that is that disentanglement was 6 years to the day from when we had disentangled his younger sister from having debris around her. Those are pictures of her off to the left. These animals have stories to tell. They are animals out there that we can get to know what they have to face. And one of the important things that we recognize now is that these animals are facing all of their threats all the time. They don't get to choose which one they're going to face. So we need to be there for them to be able to make a difference. This is one that we never thought we'd have to face. After one of the offshore Grand Prix races, in 2006, a dolphin was reported with fabric around its body. We went out and found it. It did indeed have fabric around its body. The fabric didn't come off, so after a couple of weeks, the National Marine Fisheries Service approved us to go out and do a rescue. We caught this animal, who already had the name Scrappy even before he picked this up. His mom was Scooby-Doo. We don't need to go into that. But what we found was that the fabric was a very large and very stretched out Speedo bathing suit. And we also learned that this is a very good material. It lasts well for 3 weeks in salt water and sunlight, except that you will grow barnacles in places where you don't want to have barnacles inside your bathing suit. We took the bathing suit off very easily. It was not stuck on him, but because they can only go forward, it was pushed back on him, and it was sawing along the front of him. And so you can see in the bottom picture, the cuts that were about an inch deep in where each of his flippers went into the body. It was a fraction of an inch away from going into a blood vessel. If it had cut into those blood vessels, he would have bled out and died. It was potentially a lethal entanglement, but fortunately we got it off of him. He has continued to swim in the nude, as have his friends, and so he's still out there and doing just fine. So the biggest threat these animals face is recreational fishing gear, and we get a large number of cases of animals that have either ingested fishing gear or become entangled in it or become hooked by it. And we have to deal with these kinds of threats. We found that there was a very large pulse in this during the 2005-2006 red tide, when the prey available to the dolphins had declined dramatically. We monitor the prey. We have since 2004. We go out with purse seining operations, like in the picture in the bottom here, and we measure the available fish in seagrass habitats throughout the bay. So it's a long-term record of prey availability. And what we found was that during this severe red tide, more than 90% of the top prey items for the dolphins were gone, and yet the dolphins stuck around. And so these animals had to make a living, and presumably when they saw that there was fresh bait or healthy catch at the end of a line, it became very attractive to them. They attacked that, and as a result, we had 2% of our local dolphin population die from interaction with recreational fishing gear. A lot of this has been sustained since that time. The upper graph here shows the instance of human interactions with dolphins, and it's on an increase since that 2005-2006 period. A lot of the increase comes from the fact that people will go out and they will feed wild dolphins. They will provision them. It's something that's really attractive to do. You don't have to pay like you do when you go to some of the places inland from here. But it's a really bad idea, and it's against federal law. So people will feed the animals in spite of signs that have been put up by NOAA, in spite of billboards, in spite of us telling them about it. They continue to feed these animals, and it changes the animals' behavior and makes them less aware of what's going on in their environment. It makes as much sense as that lower right-hand corner picture, feeding a wild animal. They become less wild. There's one case of a dolphin up in the Florida Panhandle that was taking undersized red snappers that were being thrown over the side of the boat, and it was so distracted that a mako shark came up and bit his tail off, and then came in and finished it off. It has consequences. Yes, it's fun for a moment for people, but how do we think these animals learn when they're at an oceanarium? They learn because they get a food reward that reinforces whatever the behavior is that they were doing right before that. And so these dolphins that come up and approach boats and are distracted are getting reinforced when they get fed, and it increases the risk to them. The second graph down shows that those animals that are engaged in those kinds of behaviors have a much higher probability of dying or becoming seriously injured at an earlier age than animals that don't engage in that. There are long-term consequences. One way of dealing with it is through interventions and rescues, and we do that. It's hard to know that an animal that's one of your neighbors is in trouble and you don't do something about it. So we do engage in rescues of these animals as individuals, and there's a number of examples here that I won't go through right now. But we find that prevention is much better than intervention. We know that the dolphins pass on the information from generation to generation through social learning. Calves watch their moms approach people and take food. How do we break that cycle? We change the behavior of the people. And so we provide written materials such as the card on the right-hand side, and much of our written materials are available on the table out there. Please help yourself to them. We do lectures like this. We write books, and we prepare other materials such as public service announcements. And here is one that we put together a couple of years ago.
Original started with 1 inch sardines. Sardines. That's what one guy. It was easy. It's called free fish. Hey, with this could kick this if people would just stop behaving.
And it's true. And you can download that video at don'tfeedwilddolphins.org. Please share it with people, send it around to people. It's also available on our program website. Other kinds of threats that these animals face are hidden ones. They're environmental contaminants. Things like PCBs, these legacy contaminants that come from other places, but they come in on the winds and they get into the water column and into the sediments, then they work their way up to the animals through the invertebrates, into the fish, into the dolphins. In this case, these are PCBs in our local dolphins, and we find that the males, the blue triangles, increase their concentrations of PCBs throughout their lifetime because they have no way of getting rid of them. And at most of the points in their life, they are above that dotted line, which is the threshold above which you would expect to see health or reproductive problems. This may be one of the reasons why the oldest male we've seen is only 52 as opposed to the female being 67. Females, on the other hand, get cleaner over time, and they go through a process called depuration, in which they will dump these contaminants to their calves through milk, because milk is fat-rich, and these contaminants bind to fats. So good for mom to be able to clean herself out, bad for especially the firstborn calf that may get a dose that's accumulated over 8 years in mom and maybe more than the calf can survive. And then there are the emerging threats, such as climate change. The upper left-hand graph shows water temperatures from our sightings in Sarasota Bay since 1993, when we began our current survey program, and it shows the usual seasonal variations. There's not a lot statistical to come out of this, but what it does show to me is that there's a general trend towards warmer winters in the area. And these winters are an important time for the animals. These winters are a time when these animals actually do much better than they do in the summertime around here. They put on blubber, they're able to sustain themselves in these waters, they don't face heat stress, and what we find is that the highest mortalities of our dolphins occur during the hottest times in the summer. So we also find they have a higher metabolic rate in the summer than they do in the wintertime. Winter's a good thing. Losing winter and the temperature changes that go along with that, the cyclicity of that, would not be a good thing. So if the waters in this area warm as part of the global processes, what are the kinds of things we might see? First of all, it's going to limit the dolphin's cooling ability if the water temperature is equal to or exceeds the body temperature. I've shown a dotted line with body temperature. There are times when water temperature exceeds that. They can't dump heat to the environment when it gets to be too warm. As their metabolic rate increases, as it does in warmer water, they require more food. But with the changes in pH and temperature and salinity that will come along with global change, the prey species available to the animals are going to change, and the specific behaviors that are needed for a specific prey will have to change. They're going to have to make a lot of changes. Warmer waters will allow new pathogens to come into the area, and longer warmer waters over the course of the year will mean that these pathogens can stay around longer. There's going to be an increase probably in the frequency and intensity of harmful algal blooms, and a change in the frequency and intensity of hurricanes. These are projections. These are not fact at this point, but it's the outlook we have for the dolphins. They don't leave the area when things happen that are bad. We define them as living in an ecological cul-de-sac. Even when horrible things happen like an oil spill or a severe red tide or a hurricane, those dolphins remain resident in those areas. They're not leaving. So what can we do to make the neighborhood better for them and help them thrive? And it's wonderful to be in front of an audience like this that has this in mind as a goal to try to make life better for us and our neighbors out there in the same area. So thank you very much.
On. There we go. Questions? If you guys have your note cards, please hold them up, and somebody's going to come around and collect them. And we will get going for a little bit here. I'll get us going with one. Yeah. Thank you. Thank you.
Only the easy ones, please.
The question is, were they able to recover through BP with your data? If you could talk a little bit more about sort of the relationship between your research and the BP.
There was a huge effort that's gone on and continues up in the northern Gulf of Mexico to try to look at the impacts of BP, not just on dolphins, but on every aspect of the environment. The dolphins just happen to be a highly visible one that a lot of people seem to care about, and so it became a dramatic example of impacts that could be extrapolated to other creatures as well. But the fact that there was demonstrable declines in health that could be identified as clearly resulting from the oil spill, demonstrable losses of individuals. They did modeling that demonstrated that there were thousands of dolphin days, it's a way of measuring them, that were lost as a result of the oil spill. And the fact that the reproduction is low, which is going to hamper recovery of those animals, all that just really made a highly visible point that was difficult for anybody to counter. The evidence was put together by a huge team of people, people from agencies as well as independent research organizations, and it was a really solid case that was made in terms of the impacts of Deepwater Horizon on the dolphins in the Northern Gulf. Have they recovered?
Have they recovered?
Oh, okay, sorry, I should have gone into that. What the modeling showed was that it's probably going to take 30 to 40 years for them to recover, assuming they're given a chance to recover. Now, in the irony of things, there are a whole bunch of organizations that are putting some of the BP recovery money towards trying to flush Barataria Bay with fresh water to try to bring back habitat in there. Flushing Barataria Bay with fresh water from the Mississippi River to bring in sediments is going to destroy the habitat for dolphins, and there won't be a chance for them to recover. So it's a very complicated situation and not straightforward.
You mentioned the dorsal fin markings. Could you tell us how local dolphins come to acquire those specific markings?
Sure. When we first started doing our work in 1970, we didn't appreciate the presence of those markings. We saw them, but it wasn't until we started working with other scientists from other places that we began to appreciate that these are individually specific markings that they acquire from the time they're born. Many of them come from dolphins biting one another. Some of them come from sharks striking them. Some come from human causes like boat propellers or entanglement in gear. And others are just really natural shapes that we can use. With enough experience and with a high-quality photograph, you can pick out a lot of distinctive individuals within a given population.
And the local population, is it rising, declining, or stable? And is the population structure kind of staying the same as well?
Good question. The population in Sarasota Bay is in a good place right now. We've had 2 very good years in terms of births and low mortality. I may have just jinxed it. Last year we had, I think, 10 calves, and those are all still alive in the area. And this year we had a record 20 calves born to the local population, and 16 of those are still going. So with that sort of success, we're looking at a good future for now, barring a red tide, an oil spill, or whatever.
You mentioned during the oil spill that the dolphins kind of stuck around in the same territory. Is there a reason why the dolphins don't migrate in response to negative conditions?
Yeah, that concept of an ecological cul-de-sac. These animals have been resident to areas for hundreds, if not thousands of years. A lot of the inshore waters in the Gulf of Mexico are only a few thousand years old, varying with sea level rise. These animals don't have any other place to go, is our speculation. The dolphins live in all the coastal waters around the Gulf. They're established in communities. These communities presumably are at the abundance levels that can be supported by the available resources. So between the established social structures, which would make it difficult for other dolphins to come in from outside, and the lack of resources to be able to sustain additional dolphins in that area, we don't see the movement of animals from one population to another.
And we're going to talk about climate change in a minute, but the rate of climate change, will dolphins be able to evolve or change to keep up with that, do you think?
That's a really good question. The species will not be in danger, but localized populations may die out in particular areas. We are hopefully in an area where there's enough temperature change over the course of the year that they'll be able to be sustained, but it's not a given by any means that we'll continue to have dolphins here. In other parts of the species range, they're seasonally migratory, like along the Atlantic seaboard. In the summer, they'll be up in New Jersey. In the winter, the same dolphins are in North Carolina. Whether something like that comes into place, I'd be doubtful, because these are animals that are evolved to be locally resident and to know local resources.
And a question about behavior. Why do dolphins throw fish in the air?
Just to make the fishermen angry. It's hard to say. Why? Oftentimes when you see fish being thrown, it'll be by young animals, and they're playing a little bit before they actually eat that. In other cases, it may be to try to break up the fish. The dolphins will eat catfish, and the catfish have spines with poison in them that can do great damage to them. But you'll go along the waters, and you'll see a trail of catfish heads still trying to swim, bleeding out, but no tails. And so these animals have learned how to handle different kinds of prey, and they've learned what it takes to be able to eat different kinds of prey fish. And so some of it may be trying to break up the fish if it's too big or if it's a specialized situation like the catfish.
And a couple questions about red tide. When you look at red tide and the impact on the dolphin population, what it causes red tide or exacerbates it? And also, when you look at deaths related to dolphins from red tide, is that considered placed in the natural category or something different?
Both of those are excellent questions. I'm not a red tide expert. I will defer to the expert from Mote Marine Laboratory to talk about that. It is something that's a natural phenomenon, though. It has been around. We expect it to occur, and when it doesn't occur, that's kind of unusual. There are questions about whether human activities are exacerbating the severity of red tides in an area. But what we find with our dolphins, at least in Sarasota Bay, is that it's not so much the toxin from the red tide, the brevetoxin, that kills the animals. That happens in other places where they're not exposed to them as much, but there are hints from PhD work that was done by Christina Kamen that suggests there may be a genetic protective factor for these animals in Sarasota Bay, perhaps as a result of having been exposed so many times to red tide over the generations. What's more of a factor for the dolphins is the loss of ecological resources. So the loss of prey caused much more in the way of mortalities, and so there was a lag from when the red tide came on to when the dolphins were dying, but it was more related to not being able to get enough to eat or eating the wrong things.
And the last question, is there an ideal age range for the reproduction of dolphins, and has that changed in kind of over the course of your research?
They have an incredibly wide reproductive range. The youngest we've seen is 6 years of age. The oldest, and we've seen this a couple of times, is 48. And this serves them very well. This kind of very broad reproductive lifespan gives the population tremendous resilience. For example, there's a disease called morbillivirus, which is kind of like rinderpest or a version of measles, that's wiped out populations of dolphins and seals in other parts of the world and has hit other populations such as along the Atlantic seaboard twice now, taking out many individuals. If what we've seen in Sarasota Bay is that our dolphins were exposed to one of these outbreaks, this zoonotic disease, many years ago, some of the individuals survived that, and those that survive over time with some degree of immunity to it are still there to reproduce, even when younger individuals that were not exposed and therefore don't have any immunity don't survive. So it's that long history of exposure. It's more than just behavioral knowledge of the environment, but it's also exposure to things in the environment that allows them to have physiological bases for surviving as well that can make a difference for allowing a population to survive over time.
Terrific. Well, thank you very much, Randy, for your time.
Okay. Thank you.